Welcome back to the building of the Cherry 3D printer. This is part 3, so if you're just starting, you might want to watch parts 1 and 2 beforehand so you know how we got to where we are and a little bit about where we're going. Today we're making some design revisions and correcting one mistake that I caught after my last video, so we'll just jump right into it. The first thing that we're going to be looking at is making it as compact as possible. I was talking to Glenn from FunKing 3D, and we were talking about the idea, and then all of a sudden I realized that there's actually enough space underneath the motor mounts here, at least width-wise, to mount the ramps board and the Arduino directly onto this, which means that we wouldn't need a base underneath. But, as I said, not quite enough height and probably not quite stable enough to be what you want it to be. So, I hit up Fusion 360 and I modeled these up. Now, these are probably actually a little bit bigger, thicker than they need to be, but I wanted to be able to attach these so that we can get some height on this, put the pieces underneath, and allow for airflow and the ramps board. And this is going to make this into a nice, small, portable 3D printer. So it's just going to sit just like that. So the plan is to mount it that way, and that should be more than sturdy enough once they're screwed into place to be able to handle the light rocking, because it's not going to be a particularly fast 3D printer. And then everything except for the power supply is going to be contained into one unit. I'm even going to try and mount a Raspberry Pi or an Orange Pi underneath it so that it's completely standalone with Wi-Fi and everything on it. So let's jump into the mod. We'll get the legs attached, and then we're going to start putting the components onto here with a more permanent status. They've just been sitting here until now. Okay, so here we are in the overhead view, and you can get a better look at those legs. You can see the spacing on them is pretty good. The actual positioning of them is going to be pretty decent, so we'll go ahead and flip this over. So I'm going to position these so they are spread out as much as possible, sort of right to the edge of these boards, just to give it as much stability as possible. Just like that and like that. And then I've got some wood screws that I picked up. Now, these are white. They don't need to be, but it's what was available. With my drill, let's see how stable that is. Now, that does slide around a little bit, so we'll probably want to put some rubber feet on top of the actual feet, but yeah, I think that's going to be fine. You're going to have a hard time flipping something like that. So the next part we're going to want to put in is the Y-axis mount. So we'll go ahead and load a motor up into it like this, and then drop it into place. And then make sure it's nice and flush and square with the back. That looks pretty sturdy. Starting to come together. Next, we can get these guys mounted up. So same practice, we'll feed the wires through the holes, get them into position. Now the only thing we're going to do in addition on this one is once it's in position, we're going to want to put the X/Z carriage on here to make sure that they're properly lined up, because we don't want to find out after the fact that they're not. So we will go ahead and slide this right down on there. It should be pretty close right off the bat with the motors in there. It's got to be pretty close. Like that. For this, we will unclip, let it drop down as much as possible, which takes away pretty much all the wiggle room, then square it off at the back. And back to our handy dandy screws. There we go. Now with it like that, we should have absolutely no problem getting that to slide up and down just like that. Now, back to the mistake that I actually caught during my last assembly. These are actually mounted upside down, so this should be like this. So, a bit of a mistake on my part. I started thinking about it, and then all of a sudden I realized that the holes for the nuts are here, and there's no way that it's going to hold it on snap fit if it's on top like that. It's really meant to ride it the other way. So, we're going to turn this to our advantage, because the other thing that this is missing is a spot to mount the end stop for here. So I'm going to 3D print a bracket. I'm going to design and 3D print a bracket that's going to fit onto here, hold the end stop in place so that this can slide across and hit it. And it's going to end up being something we're going to have to do anyways. So we'll start off by unhooking the belt. So now the thing we're going to have to do, unfortunately, well, the thing I'm going to have to do is disassemble this part of the axis here. Bit of a pain, but hey, I make the mistake and then you guys don't, right? Well, now I'm kind of wondering if we can get away with this. If I mount the hot end with this the opposite way around, like this, then I'm going to be able to regain that much of the Z height. So the Z height's going to start from here. It's going to be able to go all the way up to the top, because that's right about down where the bed's going to end up sitting. So, oh, it's a hard choice. Do we risk it? Wondering if the hot end is going to be... I don't think it's going to be too close to the PLA that it's going to cause issues down here, provided I keep this turned the right way. I've certainly had PLA that's sitting closer to a hot end that's running hotter for like a cooling fan and stuff like that, and it hasn't degraded enough to, or it hasn't degraded at all. I think we're going to go for it. I mean, it's 3D printed parts, so worst comes to worst, if this doesn't work out for me, then you guys know not to try it in the future. Now, unfortunately, by this time, my 5mm threaded rod still hadn't shown up, so I went to the home hardware near my place and picked up some threaded rod that they didn't actually have the size on, but it looked pretty close to the 5mm. It's not metric, but this actually gives us a bit of a learning opportunity, because I'm going to be able to show you guys later on how to calibrate no matter which threaded rod you're using, which is important. So I start off by cleaning the edges of the coupler. There's a little bit of an elephant foot situation happening on them, so I use my X-Acto knife to clean out the holes. Next, I pre-threaded the screws I was using to do the coupling through the freshly cleaned holes so that they would be nice and lined up and ready to work with. Then, with the two pieces lined up, I went ahead and sandwiched the threaded rod in between the two pieces of the coupler. Then I used my drill to tighten the connection around the threaded rod with the top two screws, leaving the bottom screws loose for the motor. From there, it was just a matter of slipping the coupler over the motor, making sure that the flat edges were lined up with the flat edges in the side of the coupler. Then finally, I tightened in the bottom screws, securing the entire assembly together, and repeated for the second motor. With both threaded rods properly mounted, it was now time to put the motors back into position, threaded rods pointing up. And now we can reinstall the carriage so that it's looking a lot more like a 3D printer. Well, now that we have everything lined up and in place, it's time to screw the motors in. I was actually able to just use the same 3/4 of an inch wood screws that I'd been using to hold everything else together to put them in. They fit properly into the holes in the actual plastic brackets, and they made it into the wood underneath, which makes it extra secure. Underneath the left motor for the Z-axis is where I chose to mount the motor for the extruder. I'm trying to turn the entire printer into one compact unit, and this is just going to be wasted space if we don't use it for this. So that's about where the bracket's going to be mounted. Using the same wood screws as before, and it's a little bit awkward to try and hold everything in place with My one hand will use the other hand to drill, but the first screw will ensure the bracket stays in place. First one's nice and secure now, which means the second one should be a lot easier. I don't have to hold the bracket in place anymore. Okay, well, first install the extruder gear on the stepper motor axle. Then we're going to place this plate over top of the stepper motor with the top part pointing towards where you want the plastic to extrude, the direction you want the plastic to extrude in. And we're going to use the long screws on the bottom to attach it. Then we're going to take our extruder arm and slip the bearing into the center of it, and then using the small black screw, you should be able to go ahead and feed that through and screw it right into the other side of the extruder. Make sure that you're feeding through the large edge and screwing into the small edge, otherwise this isn't going to work all that well. Then you want to slip the plastic sleeve into the large hole just underneath the Bowden coupler, which is going to act as a bushing for the entire assembly. Then you'll use the medium length screw that came with it, which is also an M3. Line it up with the motor, and then you should be able to just screw it in, and the plastic should stop it from getting so tight that you aren't able to free move it once all is said and done. My kit was missing a screw, so you should actually have one more screw to go into the top right of the assembly at this point, or before this point rather, before you install the arm, but I may do without. The 3 should be sufficient. The other thing not pictured is installing the Bowden connectors. They only fit into the screw holes rather, one on top, one on the bottom, so you should be able to install that without too much hassle. Then I popped into Fusion 360 to design an endstop holder and accidentally made this proton pack. No, but in all seriousness, I wanted to build something that had a spot for me to slide the Bowden tube through, as well as cable management, and something that the endstop could just snap into. So this was the first iteration, and not quite the final product, but you guys get the idea of what I was going for. Well, with my endstop holder printed, it was time to mount it up, so I started off by pushing the M5 screw through the hole in the middle of it, then lined it up with the hole on the axis and slid it into place. Next, I snapped the end stop into place so I could make sure that the positioning was appropriate and that it would be triggered when the carriage moved across to the left-hand side. As you can see here, you just line it up, puts a little bit of pressure on it, and it snaps into place with a friction fit with the 2 clips that I included on the sides. Now it's time to slip the Bowden tube through the included holder on the left-hand side of the bracket. As you can see, it's a slightly snug fit, but that's what you want. You don't want it slipping around too much. And just feed a fair amount through. Basically, you want to make sure that you've got enough to make it from the top of the axis all the way to the extruder without putting too sharp of a bend on it. Here you'll want to snap the hot end temporarily into place so we can measure out how much of the Bowden tube you're going to need to make it from the Bowden tube holder on the left to the actual hot end. Again, you want to make sure that you leave enough slack that it doesn't bend, but you don't want to leave any more slack than you have to because you want to keep that path as short as possible. So you can see here I test move it back and forth side to side to make sure that I've got the right amount. Then just use a pair of pliers or flush cutters to cut it to size and then press it into the Bowden coupler on the top of the hot end so that you can make sure that your length is accurate. And that looks pretty good. Now this gives me a chance to demonstrate a step I actually missed in the previous videos, and that's installing the belt on the x-axis. So start off by making sure that you have an ample length of belt that'll make it from one side to the other, and we're going to feed it over the bearings, flat edge down, then up over the pulley, and then back over the bearings on the other side. And you're going to feed enough through that you can comfortably attach it to the screw on the left-hand side without having to put any extra force on the motor. From here, just wrap it around the motor, and then using a cable tie, you'll put the cable tie around both parts and then pull the belt tight against itself so that it can't come loose. It often helps to actually start these cable ties off beforehand, then couple it together. Then all you have to do is worry about pulling it tight and not trying to line one end of the cable tie up with the hole on the other side. Make sure that you don't leave too much of the end of the belt at this point because you don't want the carriage running over it and causing a problem later on. Then we basically just repeat the process on the other side, pulling the belt as taut as you can. Within reason, you don't want it to be as tight as it would be on a traditional 3D printer because the motors are lacking a bit of torque, but you want it to be strong enough that it's not going to slip missteps or otherwise have a bunch of slack in the middle of it. Now it's time to move on to cutting the wood for our bed. So we're going to start off by putting the end pieces on the y-axis, then using a measuring tape, we're going to measure from one end to the other to figure out how deep the piece of wood needs to be. Whatever measurement you get here, you're going to add 1 inch to create a little bit of an overhang on either side. It'll make it easier, especially if you're going to clip something to it later on for the bed. Then you'll measure the distance in between the two pieces that make up the z-axis, and then again, actually in this case, you're going to subtract 1 inch to allow for clearance on either side. Using your measuring tape and a flat edge, now it's time to mark off the rectangle that is going to act as your bed, at least the underneath of your bed. I'm using a scrap piece of 1/8 inch MDF. You should be able to use anything. You're going to want to be careful with the weight here though, because again, these motors aren't super powerful, so you don't want to strain them any more than you have to. The cuts on this don't have to be completely perfect in this case. When you're measuring out, if you don't have a square to use, then I'd recommend measuring up multiple times and putting dots on the board and then basically playing connect the dots to get as close to the measurements as possible. If the cuts on this are a little bit off, not too big of a deal. As long as your bearing holder is installed square, then your bed will move square against the hot end and you'll still get accurate parts. With the wood clamped to my desk, I use my jigsaw to cut along the line. Remember that you want to keep the blade just to the outside of the line. If you're on the inside, then you're going to remove the blade width from the actual board that you're cutting. And if it's in the middle, then you're removing half a blade width. So the idea is to get rid of the line, but nothing else. Now you can lay your y-axis out flat along the board that you just cut. Then put it on your desk and with a piece of sacrificial wood underneath, or at least making sure that it's not over top of your desk, you're going to find a drill bit that's small enough to fit through the holes and go through the wood. Now, it's incredibly important that you get this as centered as possible. I end up screwing up a little bit, which doesn't end up being that big of a deal, but you want to make sure that it's as close to centered as possible. So find a drill bit that fits into the holes but doesn't rub against the edges. You don't want to take out any of the plastic. You only want to go through the board. These are going to be your pilot holes that you can enlarge later if need be, and you're also going to want to countersink them. With all 4 holes drilled, you can now use your drill with a larger bit to create a countersink hole. You'll want to be careful while doing this though, especially if you're using thin board like I am. Going too deep means you could potentially ruin the structural integrity of the board, and it'll affect the quality of the prints that come off of it later for sure. Now we'll go ahead and put screws into the holes. If they are too tight, you can drill the hole out bigger. If it's just tight enough, then you can actually thread it in, which will give it a little more structural integrity. I'm using M3s that are 40 millimeters long here. They aren't long enough to make it all the way out to the other side of the plastic, but the plastic is tight enough that when I put the screws in, they bite. So for the time being, I think it'll probably be okay. In the long run, I may need to replace these with longer screws and then add lock nuts to the bottom of them. So that may be something you want to keep in mind as well. With all 4 screws in place, you can take this step. It isn't necessary per se, but it will let you know if you're going to run into trouble, and it'll answer the question as to whether or not it's an issue squaring it up on the frame. Basically, what I decided to do at this point was to screw it halfway to the frame and make sure that everything fits and lines up properly. That way, if one of the screw holes is a little bit off, I have a chance to fix it before everything's remounted on the frame and I have to start doing disassembly to get it together. Again, it's an extra step. It'll take you a little bit extra time, but it might be worth it. With my test fit done, now it's time to reinstall the y-axis and to assemble the bed. Make sure that there's no dust on the smooth rods. That's why you see me clean it there. There's a little bit of dust on the end. I just wanted to make sure I didn't get any dust into the actual bearings. That would be no bueno. And now it's time to install the belt into the y-axis. This goes in pretty much the same way as the x-axis one, so you'll feed it through one side, and then you'll feed it over one of the bearings around the pulley, and then over the other set of bearings. And then on the other side, you feed it out through the hole that will make it line up straight. In this case, it's the one, I believe, on the right. Then fold it back over, stick it through the left hole, and cable tie it into place. On the opposite end, with a pair of flush cutters or with a pair of pliers, cut the belt to length, making sure to leave enough slack that you can then fold it over. And then fold it over, tuck it into the other hole, and repeat the process with another cable tie to secure the entire thing. Again, make sure that the belt is adequately tight that it's not going to slip, but not so tight that it puts a ton of force on the motor. Now is when you will want to install the end stop for the Y-axis. After this, it's going to be closed in with wood, so I was able to again get away with using just a wood screw here. It wasn't thick enough that it would make any contact with any of the connections on the board, and I'm able to get away with basically just putting a single one in the center. You may wish to put more screws in, you may wish to put a rubber bearing around it just to make sure that it doesn't ground out against anything, but with this here I was able to basically just screw it into place. In this case I'm using a 1/2 inch brass wood screw. If properly installed, the lever should overhang the wood, which will allow the orange end part of the Y-axis to hit it when it comes back in. Now place your wooden board back on top and go ahead and screw it back into place to complete this component for the Y-axis. And that'll do it for the Cherry 3D printer build part 3. Part 4 will be the final electrical wiring, calibration, and hopefully our first print. Beyond that, we'll do another episode on some enhancements and some cleanup and setting up an orange pie with it, and this project will be done. So, if you like this video, toss me a thumbs up. If you're new here, subscribe and click the bell so you're notified when new content comes out. If you've got comments on this build or suggestions on how you'd have done it differently or made it better, toss it in the comments below. And likewise, if you have something you'd like me to look into or another project you'd like me to cover in the future, let me know. Until next time, I'm James from Print and Play, and stay creative.